Swayam Prabha. Digital India. Educated India.
This is the last assignment for this course. So we'll do decision making today. So first thing is to optimize. So this will be a posteriori approach that we are going to do. So this is a little bigger problem. I thought we should graduate out from two variables to little more variables. So there are two functions, as you see, f1 to be minimized, f2 to be minimized. There are 6 variables. And there are about 6 constraints and these bounds that are there. So you can go to the, well, if you are familiar with PyMu, the Python, you can take it from GitHub, or you can use the MATLAB code that you have now, right? The NSGA2 should be enough because there are 2 objectives. Okay, code them so that there is no error. You may want to find if I've already coded it as one of the cases. If yes, then fine. Sometimes I have different versions of this. Make sure it's the same coefficient, everything you have. So once you run this with 100 population size, 0.9 mutation probability, 0.167, it's usually, as I said, 1 over the number of variables, so 1 over 6, and eta c, eta m, the standard values. We run little longer because this is a little complex problem to solve. So to be sure that we get to very close to the Pareto set, we let us run a little longer. And then you show the non-dominator solutions in the objective space plot. So I have a little solution here. Let me see. I'm just going to show you. Yeah, maybe this is case 14 already there. You can check, but check with the number. Just go through and see if the formulation is exactly what I have asked you to do. Okay, so then when you run it, you're going to get this kind of Pareto set. Okay, f1, f2, there is 1, 2, there is a kink here a little bit, 3, 4, 5 parts of it. Okay, they look like straight line, but they are not. Some of them are straight, but some of them are not, as you see. But this is your Pareto set. You see, it's kind of so there are several knee points. One is this knee point, another is that knee point. Usually for decision making, you prefer those. If you go to the ideal point from here, it will be somewhere here, right? And then take the one that's closest. If you first have to normalize 0, 1, 0, 1, and probably this point here somewhere will be the closest if you do the compromise programming, right, like the chemical engineers do, right? You find the closest one. But if you use this other 2 I asked you to do, one is the ASF method. So what you do now, you don't optimize the ASF function. What you do is, this is your search space. Each of the points f1, f2 you have already. So it's a posteriori we are doing. First we find this 100 solution because you use 100 population size, so you get about 100 solution. And now each of the solution we find the ASF, and there was a function I gave, right? Max of there will be 2 components, one with f1 minus z1 divided by w1, f1 minus z2 divided by w2. W1, w2 are mentioned in the question. And for each of them you compute ASF and find the minimum one, which solution corresponds to the minimum. That's not an optimization, that's just a search, right? When you do that, I found this one, I put it little bigger circle, this point turns out to be the best for ASF. Then use another method, which is, so here is the code for that. The C is pseudo weight method. We talked about pseudo weight. You have the formula in the slide. And now you compute pseudo weight for each of these points based on their maximum values. The formula will tell you. And then I think I asked you which pseudo weight is close to 0.25, 0.75. When it's 0.25, 0.75 means f2 is 3 times more important than f1. So that means you are going to have a solution closer to the minimum of f2 because f2 is given more importance. So here is f2. Minimum of f2 is here, so I got this point as a result, which seems to be okay. It's closer to the minimum of f2. You can try by changing these weights and you will see that you will find different results you are going to pick. So that's your exercise for the question 1. which you can do it at home and submit tomorrow. Weight is given 1 and 0.5. You can normalize it to get sum equal to 1. You could do that, or you could just use 1 and 0.5 because it's a constant that you multiply both of them with, so the max is not going to change. Not necessarily. You don't want to use negative values there. Negative weight has no meaning. So this basically says W1 is twice as important as W2. So you could have done 0.6667 and 0.333. You'll get the same result. But this is important. This is in the context of F1 and F2. So when you see there is a negative value here, so when you actually, this function was to be maximized, but I've actually converted it to a minimization for you already. So that Z ideal, this is not ideal, this is Z bar is minus 220 and the other one I want to have 0. So we use this division by W here. So yeah, you just have to compute this quantity for every Pareto solution and then look for the one having smaller value. You should normalize before doing anything. Here, of course, in ASF, it's usually not necessary. Your W should take care of it, but it's a good idea to normalize. So I would say put a tilde on top of F so that you normalize F to get normalized F before you use it here. Z should also be normalized. Let me check the solution if I have done that so that we have similar results. If not, I will ask you not to do so that we can grade it properly. Let me see the solution. I got the data and then ASF is calculated here. No, I haven't normalized. I just used the data. So for this problem, let's not normalize. But in any other problem, we would. And it doesn't get that much affected for ASF, whether you normalize or not. So, okay, so to answer your question, let's not normalize. Then we'll have exactly the same result. For pseudo weight, of course, there is a normalization inbuilt. So you don't have to normalize for pseudo weight. Okay? Good question. Yeah, next question. Yeah, this one you see is already normalized with, so you don't have to. Here my target is 0.25, 0.75 as pseudo weight. So pick the one that is, so for every point that you found, there will be a pseudo weight coming out from this equation, and then you see which one has the closest Euclidean distance from here, and that's the one you pick and show it on that plot. So with this you have optimized and you made decisions twice, one with ASF approach, the other one with the pseudo weight. Oh, I have not given you the trade-off, so that's a bit more complex to do, so let's not do the trade-off here. ASF and this, these are the two. So that's why this is called a posteriori, because I'm first finding the whole Pareto set with about 100 points and then picking one from it. And it also shows that what decision making algorithm you use, the final result depends on that, because there are two different places, right? Make sense? All right. Now is the interesting problem. Is the second one where we are going to, I said here, forget these dates on everything because I got this data for this date of the flights using Expedia or Kayak, I forgot which one I used. You are planning to go from a weird airport, and sometimes I go to this airport in Italy. It's a kind of touristic place, La Mezzia Terme, small airport, and then to EDI, to the Edinburgh, which is a big airport in UK. So reason I choose this is you have to make few stops. There is no direct flight from here to there. So there are 4 options I found from these website or booking websites. Each of them has different cost. You see, going from $312 to $1,025. Okay, so obviously $1,025 should give you some benefit, like minimum time or some other thing, right? All of these are here. I'll show you, but there are 3 things we are interested in. 3 criteria we are interested in looking at. First is minimize the total travel time, starting the flight time to finishing up the flight time, and you know, anything intermediate in between. So total time that you reach the airport for the flight and you land at the airport. Okay, minimize the cost, overall cost of flights only. Minimize number of total flights, how many flights you are taking. So all these have to keep in mind before picking one, and probably you do the same when you book a flight, right, or a train.